Hello, everybody, and welcome back to 8th grade math. Today, our lesson is all about graphing systems of equations. So, getting into this new unit on systems of equations and just kind of seeing the different ways we can do this, today our focus is on graphing. Our goal for today is to be able to find the solution to simultaneous linear equations. That's the same thing as systems of equations. And our focus is graphing. Now, starting out with this an opening question. So I'm trying to see how much you all remember from our last unit where we focused on graphing lines, finding the slope, all that stuff. What you're going to do is you are going to quietly for about 30 seconds see how far you can get with graphing both of these lines on the same graph. And then I'll give you guys a prompt for whenever you guys can start talking to your teammates, and then you can get some help from them, or you all can compare your answers. So 30 seconds of quiet time. I'm going to start that now, and we'll come back and discuss it here in just a second. Okay, so after completing this is what your graph should have looked like. And just hearing some of the groups share out, just talking about a few of our struggles that we may have encountered. I know that several people have struggled with, 4x, they want to start at 3, then go up 4, right 1. Can't do that because our graph doesn't go that far. So you had to remember to reverse that and go down and left. So just making sure everybody did that. And then also with the -1 slope, remember that you're going down 1, right 1, down 1, right 1 to get those points. Now, what do we notice about these two lines? Obviously, they cross, or a better word, they intersect at -1, -1. So really, that's the most complex part about today, is finding where they cross. Well, maybe that and converting to slope-intercept form, but we've done all that in the past unit, so we're just kind of combining all of that today. But what you just did when you graphed this, you actually solved a systems of equation. Before we even got into the bulk of the work, you've already done it. So let's talk more specifically before we get into all the different steps about what is a systems of equations. So we have a set of equations. Could be more than two, but we're going to focus on two, a set of equations that share the same solutions for both x and y. Different ways we can solve this. Today we're focused on graphing. We can solve by graphing, elimination, or substitution. And this goes out of order just a little bit. We'll do graphing first, then we'll do substitution, and we'll do elimination last. Now, so this sets up some nice little steps here for us to follow. It says, be sure both equations are in slope-intercept form. And it says, if not, you have to put in that form by balancing the equation. And we've talked about that in the past. We'll look at it again. Then step 2 would be to graph equation number 1. And just a little reminder here, start with your y-intercept and then use the slope, rise over run. Step 3 would be to graph equation number 2. So start with the y-intercept, use the slope. Then find the place where both lines intersect. Then there are the values for x and y. Check your work when necessary by substituting x and y back in. So substituting the x and y back into both of those equations to check and be sure that both values work for both equations. Now, here we have our first problem. It's breaking it down into those steps, and we're going to do that real quick. So step 1 is, of course, to be sure that both of these are in slope-intercept form, y equals mx plus b, y equals mx plus b, because that's the easiest way for us to graph it, and they are, so we're ready to move on to step 2. Step 2 is to actually graph these. So I'm going to start with equation number 1, and I'm going to begin at the end. That's what I always tell you guys, begin at the end with our y-intercept. So this is a 3, so I'm going on the y-axis and finding 3. I'm going to put a dot there. Then our slope is 1/3, so rise and run. If it's positive, we're going up and right. So up 1, right 3. Then to get the other side of your line, we have to reverse these. Instead of up and right, we're going to go down and left. So starting back there at our original point, down 1, left 3. So a good little refresher for anyone that has forgotten those steps. Now, going to move on to our next equation, which is y equals 2x minus 2. My y-intercept here is -2, so I plot that first. I have a slope of 2, so I need to remember to change that to a fraction. Once again, it's positive, so I go up 2, right 1. Up 2, right 1, up 2, right 1, up 2, right 1. Aha! I found where they intersect. These intersect at 3, 4. So now I know my answer. I know that x is 3, y is 4 for both of these equations. Whenever you guys do it today, I'll ask that you leave it here in this coordinate form. But know that that's what we're saying here. We're saying x is 3, y is 4 for both of these equations. And now we're going to prove that by checking our work. So here we have these equations. We're going to write these out. 1/3 x plus 3. We are claiming that x is 3, y is 4. So I'm going to substitute these in. So in place of y, I'm going to put 4. And in place of x, I'm going to put 3. And I'm going to solve this out and be sure this works out. So 1/3 of 3 is just 1. Bring down my plus 3, bring down my 4. This is the only part that I've solved so far. 4 equals 1 plus 3. I believe that's a true statement. So that works out for that equation. Now I'm going to check the other one and make sure it works for it. So y equals 2x minus 2. I'm just going to go back to that purple color so I don't get these confused. Y equals 2x minus 2 is our other equation, and we are claiming that, once again, x is 3. So I'm going to substitute that in, and we are claiming that 4 is y. So I'm going to substitute that in. Okay, very quickly, 2 times 3 is 6, minus 2 is 4. 4 does equal 4. We're good. So we found the value for x and for y. So since that was already very simple, we've done 2 of them, we are now going to work with our group to attempt example 2. So go ahead and do that. We can go ahead and start talking during this process because the next one we'll do on our own, and that'll be quiet work. So go ahead, get started, and we'll check back with each other here in just a second. Okay, so compare your answer to mine. Obviously, this first one, we started at -4, and our slope was a +3, so that means up 3, right 1, up 3, right 1, up 3, right 1. And in our second equation, it was starting at +3, and our slope is -1/2, so going down 1, right 2, down 1, right 2. And then we can see that it does cross at 2, 2. Now, example 3, you are going to do entirely on your own, so this will be quiet work, and then we'll compare answers here in about, I'll give us about a minute and a half. So go ahead, work quietly, see how much you can do of this one on your own. Okay, after comparing with our group, now you're going to come up here, well, you're going to look up here and check and see if you have done yours the same as mine. As you can see with this first equation, we have started at +1. Our slope was -1, so that means down 1, right 1, down 1, right 1, down 1, right 1. If anyone ran into any difficulty, it's because they forgot x equals 3, how to graph these horizontal and vertical lines. So remember, if it's x equals 3, we're going on the x-axis, finding 3, and then drawing a line perpendicular to the axis that goes through that point. So That makes our solution 3, -2. Now for the most complex part, and it isn't even really that bad, we have got to change these into slope-intercept form so we can more easily graph them. So I'm going to rewrite 2x plus y equals 1 so I can manipulate this equation. I want y by itself, so isolating that variable by doing some inverse operations here. I've got to move the 2x to the other side of the equation, so I'm going to do the opposite. I didn't stack these up because I noticed a lot of students will go 1 minus 2 whenever I stack these up, not realizing that these are not like terms, so I kind of just stagger them off from each other. But when I rewrite it down here, I like to put the x up front, so it is true y equals mx plus b form. Now that is something I can easily graph. The second equation, x minus 2y equals 8. Now going to try to get that y by itself one more time. There's a little bit more going on with this one. I've got to move the x by subtracting it because it was positive. That cancels. I'm left with -2y equals -x plus 8. Now the problem with this one is that we do have a coefficient on the y, and we've got to get rid of that. So that means I am dividing both sides by 2. And we usually joke about this and call it pretzel division, where we're being sure that both terms get divided by that -2. -1 divided by -2. Negative divided by negative is a positive, so we have 1/2 x. Now completing the other half of our pretzel, 8 divided by -2 will be -4. So now we've made sure both of those are in slope-intercept form, and we can easily graph those. So what you're going to do now is, once again, on your own, you're going to practice. I'm going to give you about 1 minute and 30 seconds again, and then we'll meet back here, compare your answer with mine, and discuss. Okay, so put your attention back on the board, check your problem with mine, and you can see here that obviously, once again, you should have started with 1, negative slope, so down to right 1, down to right 1, and then here you should start at -4, and you have a positive slope at 1/2, so up 1, right 2. Could have stopped that line there because we already found the solution, but I went ahead and did another one, up 1, right 2, and we see that it crosses, at 2, -3. So let's take a look at Desmos graphing. I have typed in both of those equations. This would be a wonderful way to check your work. Obviously, being sure that you are attempting the problem, doing it correctly, but a good tool to check and be sure that you graphed it correctly would be to type both of these in and see, does it intersect at the same place your problem intersected when you graphed it? Obviously, ours crossed at 2, -3, and this crosses at 2, -3 as well. So definitely a way for you to check yourself. And that's it for our lesson. What we're going to do now is work on our independent practice, and have a great day.